A man walked into my rental office on a Tuesday morning and asked how much it would cost to drive to the nearest star.
Not the sun. The next one.
I quoted him. This is that quote. Proxima Centauri sits about 40 trillion kilometers away, 25 trillion miles if you're still using those. It's the closest star to our solar system, 4.24 light years, if that helps. It doesn't. He wanted a mid-sized sedan, automatic transmission, good gas mileage. He had a long weekend planned. I pulled up the rate sheet. Highway speed, let's call it 100 kilometers an hour, puts you at 40 trillion kilometers in 400 billion hours. That's 16.7 billion days. 45.6 million years, one way.
Does that include the return trip?
It did not. Round trip runs you 91.2 million years. For context, modern humans have existed for 300,000 years. You'd need to invent agriculture, writing, and the wheel 152 separate times. Every single one of those civilizations would rise, flourish, and collapse before you made it halfway there.
What's the mileage rate?
I told him most customers find the sedan impractical for deep space applications. We do have alternatives. Voyager 1 is currently our longest running rental, launched in 1977, still going. We haven't gotten it back yet. It moves at 17 kilometers per second, 73,000 years to Proxima. Better. But picture it as a drive back through time. You'd leave today and arrive 73,000 years in the past, deep in the last ice age, before farming was even an idea, before writing, before recorded history of any kind. The Parker Solar Probe is faster, fastest thing we built, 692,000 kilometers an hour, holds the record. 6,600 years. 6,600 years ago, farming was still spreading across Europe. Writing hadn't been invented. The pyramids were 2,000 years away. You'd launch before the Bronze Age and arrive sometime next week.
You got anything faster?
Light itself makes the trip in 4.24 years. 300,000 kilometers per second. That's 7.5 times around the Earth every second, constantly. Unfortunately, his sedan does not go the speed of light.
What if I floor it?
Nothing with mass does. According to special relativity, as you approach light speed, your mass approaches infinity. The faster you go, the heavier you get, exponentially. Accelerating an infinite mass requires infinite energy. We're currently out of stock.
What about, future stuff?
I walked him through the brochure. Ion engines are nearly 10 times more efficient than a chemical rocket. Nuclear thermal lands in between, double the chemical, a fifth of the ion. Our premium tier, trip time, still centuries, plural. Fusion is also in the brochure. It doesn't technically exist yet, but the brochure is optimistic. Best case, you leave as a young man and come back a very old one. Assuming the engine we haven't invented works on the first try. Antimatter would work beautifully. Perfect fuel, 100% converted to energy. It runs about $62 trillion a gram, and you'd need several kilograms. We do not carry it.
Nah, I'm good.
I mentioned that even if you solve the speed problem, space between stars isn't empty. The interstellar medium is mostly hydrogen. About 1 atom per cubic centimeter. Doesn't sound like much. At relativistic speeds, you're hitting trillions of hydrogen protons per second. Everyone arrives with the energy of a particle accelerator. Your windshield becomes a continuous nuclear event. The occasional dust grain hits like a rifle round. Except it's not occasional. You're traveling through 40 trillion kilometers of this. Radiation exposure over decades or centuries in deep space is also not covered by our standard insurance. Cosmic rays, solar wind from 2 different stars, and the background radiation of space itself.
Is there an upgrade or something?
There is one benefit at relativistic speeds: time dilation. Travel near light speed and time passes slower for you than for everyone on Earth. From inside the car, the trip could feel like a few months. Unfortunately, Earth's timeline continues at its normal pace, 4.24 years minimum, each way, no matter how fast you feel like you're going. You come back a few months older, Earth would be 8.5 years older, minimum. Your friends moved on, your parking spot is gone. Best case scenario, assuming you somehow hit near light speed in a mid-sized sedan.
So it's kind of like time travel.
Also, any message you send home takes 4.24 years to arrive. The reply takes another 4.24. 8.5 years round trip, minimum, for any communication. Customer service response times are not ideal. If you have a question about the return policy, you'll get an answer sometime in the next decade.
Wait, are you trying to talk me out of this?
I told him I was simply providing the quote. He wanted the mid-sized sedan at highway speed. That's what I quoted him. 45.6 million years at 100 kilometers an hour. Round trip, 91.2 million. I printed the contract. Mileage came to 80 trillion kilometers. Round trip. At 12 cents per kilometer over the included allowance, he owed $9.6 trillion in mileage fees, plus a late fee. The vehicle was due back in 3 days. 3 days. Not 3 days of subjective traveler time, 3 days Earth time, 72 hours from now. He asked about the gas mileage. I told him the sedan gets about 30 miles per gallon. 80 trillion kilometers is about 50 trillion miles. At 30 miles per gallon, that's 1.7 trillion gallons of gas. There are no gas stations between here and Proxima Centauri. I mentioned that.
It's cool. I'll fill up before I go.
I told him to take his time. He had 45.6 million years. He signed the waiver, initialed every page, declined the insurance, and left. I haven't seen him since, but I'm not worried. Subscribe if you like. It's free, and you won't need the collision damage waiver.